I'm Subhas. I'm an engineer at GoEuro. GoEuro is a Europe-wide travel aggregator, travel search and booking engine. We operate across 12 countries. We cover thousands of stations, 200 plus providers, 10 million plus monthly searches. It's just searches, not sessions. Huge number of volume, and one of the more successful startups out of Berlin. Not the most, but one of the more successful startups. And I'm an engineer there, leading the CI/CD platform team and the transition to Kubernetes and Docker. So our transition journey goes back so we scaled up from 50 engineers and 8 to 10 services to 150 engineers, 50 services, new ones starting every 1 or 2 weeks. We scaled up from 10 coordinated releases to 150 plus independent releases happening every week. That number is not definitely an upper bound. We are just warming up. And we went from legacy infrastructure to CI, CD, Docker, and Kubernetes through all kinds of legacy problems. Like we had all sort of integration patterns, file-driven integration, shared database, REST, message queues, metrics-driven integration, like one app writes to Graphite, another app reads from Graphite, like you name it, you got it. Compile time, additional artifacts, like probably, and across the spectrum, you also had all sort of problems like, dev hacks for ops problems and ops hacks for dev problems, like all the things that you would expect when devs and ops work in silos. Yeah. So we finished the transition across 4 months in the entire company. And so before I go into the actual transition journey, I would first like to skip ahead and show you where we are right now, and then work backwards to see how we got there. So let's first start with development. We'll start with the most basic unit. From the bottom up, the first thing that we have is the first thing that we enable is development in the cloud. So we had something called Hyper-VM. This is before Minikube became easy to use. So the Hyper-VM is just a single node Docker and Kubernetes cluster, which is really optimized for development. Like you can Docker build on the same node and kubectl run on the same node without having to push your Docker image to a central registry. And this VM image also adds a little bit of metadata-driven customization. Like you can say boot these services, like apply these Kubernetes services when this machine starts at boot. And we also have everything else that is required for developing in the cloud, like making Docker work with our DNS, like Docker inside Docker builds work with our DNS, and integrate with our internal networks, all the legacy ops hacks for devs hidden inside, and build arguments activated Docker patches, because we don't want to distribute tools, we want to distribute services. So we just have the regular Docker client, and this Hyper-VM runs a Docker server, which is patched. And if you specify certain build arguments, like if you want build time caching, like if you want to mount volumes during build, remember that we are operating with lots of legacy services, you just use build args for it. And at the same time, if you just point your Docker command line to a proper Docker mission or Minikube, it still works perfectly fine, except a little slower. Yeah. And this VM is always our first point to begin upgrading Docker or Kubernetes versions from dev to prod. It's just Minikube in the cloud, but this is where I just want to start with slow. So developers, every application repository has an ops folder. Again, I'm showing you where we are, and then I'll later work backwards. So every application has an ops folder, which contains all the ops requirements for that, including the Docker file, the Helm chart, a ci.yaml, we'll see more about that soon, the make files, and everything else. Right. So most of the DevOps requirements are self-contained within the application repository. So after applications have created their ops folder with the necessary Helm chart and the Docker file, we have something called as Y8S. It started out as a pun name, but the name just kind of stuck. So it's nothing but YAML Kubernetes sharing, again before Helm. And so what we did was, this was when Helm was transitioning from the 0.x to 1.x releases. So what we did was we adopted the Helm chart standard. So, and we just render the Helm chart as a service. So you can call an API. I'll just show you up next. So you can say HTTP y8s.internal and just give it any repository, and it will check out that repository and render the Helm chart and give you back the output. So kubectl has this really nice but hidden feature that you can use HTTP URLs when you are applying with kube control, and we just use it to the max. And and why we do that is because, and we also dogfood the same thing for our own services. Like all of our DevOps services that we deploy in all the clusters are also using the same y8s tool. And the y8s service also supports additional REST options. You can pass in parameters to the templating, but we just expose a slightly smaller subset. Like all the repositories are supposed to render with only one variable called as env. And the env is like we have predefined environments, development, testing, mock, QA, pre-prod, prod EU, and our production region. So there is a certain set of environments that every service must support, and outside of that, everything else is additionally configurable, but they should work out of the box. So in addition, the YAML sharing service also, when rendering the Helm charts, it prints out a whole lot of annotations to every resource, like including the git commit ID from which it was rendered from, the parameters using which it was rendered from. We can always trace back running services to source from how they were generated. So this is our development landscape. So we have ops folder in all the repos, Dockerfile, CI YAML, and everything else. We have the YAML sharing service and the Hyper VM to develop in the cloud, where developers can just say kube control apply all the services that they want. Right. So this is from the development, and let's move on next to the integration cycle. So we have the ci.yaml file in every repository, and we decided not to reinvent any new CI contract or a new different YAML language. So instead, what we did was we adopted the GitLab CI YAML design. Like GitLab has a really nice YAML syntax that allows for pipelines and stages and cron jobs and everything. So we adopted GitLab CI YAML, but then we converted those into CI jobs on our own terms. Like we filled out everything else, like all the plumbing. We basically made the choice of CI tool independent for the developers. Like today we use Jenkins build pipelines because build pipelines support manual checkpoints. Tomorrow we could switch to GoCD and no developer would notice. And we fill in everything else, PR checks, manual checkpoints, cron jobs, distributed build caching, Docker inside, Docker builds, like all the stuff that you have come to expect from a Dockerized environment. Slack notifications, release procedures, filling out Excel sheets, all of those are automated inside. Developers just declare their jobs in this format. So they say, this is the image that I want my build to run on, and these are my jobs, and these are the stages in which my jobs runs on. And for every job, they can also specify an environment, which is QA, production, pre-production, and so on. So this is the GitLab YAML syntax. We will come to the credentials part later, and we build out the rest of the whole pipelines. And the contract for the pipelines is really simple. Every build runs in an agent, which is a Hyper VM. Like that's why I started with the Hyper VM in development. All the Jenkins agents are Hyper VMs. In addition, they have Jenkins agent running. There is nothing else different. It's like they are operating on the same dev mission that they are used to. So, and the other contract of the build is that when your build starts, Docker and kube control are readily configured. Just start using it. Like you don't have to get the credentials or anything to point to QA or pre-prod. So if you say that environment is QA, well, you get a ready connection to QA when your job runs. If you don't specify an environment, each job is running in its own agent with its own isolated Kubernetes. So they can use it for doing end-to-end tests and so on. Right? And the other thing is that all jobs are recreated from source every 2 hours. There is no possibility of clicking and configuring a Snowflake CI. And we encourage early integration tests, kubectl apply, y8s, any service that you want, and hit it with your end-to-end tests. And we take jobs all the way to production. Like, we don't drop them off in pre-prod, and then, like, DevOps doesn't take over releases at any given point. We let applications go all the way to prod by themselves, but we ensure certain amount of safety, which I'll cover in the upcoming slides. Yeah. So this is a closer look. So if you don't specify an environment, the agent is a Hyper VM. You can start applying and running your E2E tests. Well, if you specify the environment as preview 24 hours, well, what it does is that when the build starts, it dynamically provisions a new Kubernetes Hyper VM and points your build to that, and then runs your job normally. Like, you can still do Docker build kubectl apply, except the agent is, except the results persist. Like, even after the job is finished, you still have the preview VM running. It's not cleaned up. Like, unlike the other jobs which use ephemeral agents and they are cleaned out after every build, this preview VM is dedicated to your pull request, and it stays after your job is complete. And you can use this to show previews to product. You can use this to do debugging. Like, you can find out why an end-to-end test is failing, and so on. Okay. So, but the build contract, the most essential part is the build contract remains the same. If you specify the environment as QA, pre-prod, or any of those shared production clusters that multiple teams are using, right, you still get the same build contract. Like, just do kubectl apply to deploy. And we'll talk about security later, so that when you do kubectl apply, you should make sure not to mess up with any other application. And there is also some amount of composition that you can do. Like, it's still the same job. If you say stage PR, those jobs are going to run in the PRs. If you say when manual, right, on normal build pipelines, when manual means it's manually triggered. But on a pull request, well, when manual means that you have to comment. Just comment on the pull request, say, trigger my job, and it gets triggered. It's still like a manual trigger. And then you can say the environment as preview 24 hours. You get a provisioned environment, and mix and match this, and you can do product demos on demand. You can do GitHub flow. Like, from the PR job, you can say name is production, a manual trigger, and you can deploy to production. So if you want to follow GitHub flow style of going from PRs to production, well, you can do that as well. So people mix and match this to achieve the desired effect in their pipelines. So we have pretty much a lot of patterns covered. Database migrations, it took us a lot of time to figure out how to run database migrations using kubectl run. Yeah. So basically, the y8s service, it just accepts content type, accept headers. So you can say, give me the migration in a JSON format. Like, give me the migration definition of the container in a JSON format, and you can run it with kubectl. So basically, instead of Docker running migrations, you can run kubectl run migrations, and they have access to all the Kubernetes-defined services and endpoints and everything else. You can do end-to-end testing, shared E2E services. Like, there are 3 major E2E suites in the organization. All of them are also treated as services. They also have their CI pipelines. They publish Docker artifacts, and other teams, kubectl run them using y8s. So they just build and run their own services, and they run the E2E tests on top of them. We also have, we were also wondering if we should add special syntax. Like, whatever you see before here is all perfectly valid GitLab CI YAML. So tomorrow if we switch to GitLab CI, nothing drastically changes. And we were wondering if we should add special annotations for booting additional services like Selenium or MySQL or so on, like how Travis CI does. But then we decided against it. Like, you can just kubectl apply whatever you want. So we did not need any additional abstractions for it. So this is our second level landscape. You have CI YAML in every repository. You have every CI agent is a Hyper VM. So it's pretty much the same contract that you come to expect, and we allow you to deploy readily to all the environments. So the last part of this is how do we actually deploy all these services once they cross the CI/CD pipeline. So we developed a simple Kubernetes API gateway proxy. It's called as Authaitis. It takes only a couple of hundred lines of Node.js code to proxy the Kubernetes API. It's so simple that we don't even have to open source it. You can bring one up just by playing around with it. So it's deployed in every cluster, and it proxies to the Kubernetes master. So people don't deploy to Kubernetes directly. They go through this API gateway, and each namespace gets its own username and password. So each team gets its own username and password, and that username and password is tied to one specific namespace. So they can deploy only to that namespace, and every other operation is restricted. So today we got to know that Kubernetes 1.6 has role-based access control. So we can easily replace this service. We can remove this after we have ported the same rules over to Kubernetes RBAC. What we do in addition outside of security is also compliance. Like, we don't want to run services that do not have CPU and memory limits in production. Like, this is not just role-based access control. This is more about compliance. Right? So we require certain annotations in every single pod and every single namespace. So all of this we enforce through the proxy. So whenever you try to apply a new deployment, we make sure that it has all the normal rules that you come to expect in Kubernetes. So again, the approach has been that instead of trying to create an abstraction, instead of trying to design our own YAML file, we rather do compliance and validation. Like, we help developers to write the correct Kubernetes YAMLs. We whitelist the resources that they can use. So right now, because Kubernetes has a lot of APIs, and we don't want this to become like a wild west where everybody uses some sort of beta or alpha API. So we rather just whitelist that only these resources can be used in production. So all of these we validate through here, and this was a major piece why we were able to take all the applications from dev to prod while still being safe that nobody else will get hurt in the process. We provide a lot of value additions in the cluster servers. Every server has a DNS registration agent that sort of automatically creates a DNS entry for all the clusters. We provide everything else that you come to expect in production: heapster, pod restart counters, logging, shipping container logs. And if the container logs are structured, we parse and ship structured logs as well. So we sort of support both plain text and structured log output. And for now, we use node ports for routing, but we are moving to ingress. And we are also working on, like, whenever you create a service, we would also like to create automatically external health checks for it. Just the same way we create an external DNS, we also want to create external health checks, like pingdom style checks for all the services. We offer additional services like sidecar containers. Like, as we said, we deal with a lot of legacy services, and some of them require like geo databases, which are like 2 gigabytes or 3 gigabytes in size, and we can't build it into the image. So there are a lot of additional artifacts that every service requires, and we just provide sidecar containers that do rsyncing of these artifacts to a host folder, to a host-mounted folder. So we provide sidecar containers for additional artifacts, and we also provide endpoints for region-specific services. Like, if a service says, I want to connect to MySQL, we make sure that this MySQL endpoint is correctly configured for that service in every single region. Basically, whatever persistent resource that DevOps provides is exposed as Kubernetes endpoints. And we do CD for our own stuff as well. And we were multi-region focused from the beginning. We did not try to hide, there are 2 production regions for GoEuro. We did not try to hide it from the developers. Developers are supposed to understand and configure their application for multiple regions from day one. Most of the time, like 90% of the time, the configuration is the same, except certain stateful applications, but we really don't want to hide it from our developers. So more and more annotation-driven services. So some of our services have problems like, suddenly crashing under load. Like we want to capture their heap dumps when they crash. We would like them to just specify that they need heap dumps, and we want to take care of it, take care of that concern, rather than them having to write the old style cron jobs in production environments. We have to give them a substitute, and we would like to drive it through annotations like thread dumps, auto-scaling with metric queries. Like I think with the recent release of Kubernetes, they have also added support for pluggable metrics. We will be reviewing that too. Yeah, external checks, status pages. Like we want to customize a lot of their functionality just by using annotations. So this is pretty much our landscape. We use the Hyper VMs only for development and CI. All our shared clusters are in GKE. In Google Cloud, in Google Container Engine. We use Auth-ITES for security and compliance, and we offer a lot of value-added services. So this is where we are. This is what it took us to get here. And so, sorry, actually, what did it take us to get here to this point from a really legacy world, right? So the first thing is that containers are a cultural change, right? So it's like all the years of working with dev and ops as silos, and now when we say that we are containerizing everyone, it doesn't mean only a deployment concern. It also means that developers are responsible for running their containers in production. So it's like we had to do a lot of presentations, a lot of emails, internal blogs, internal emails, call it lobbying. And by the time we actually started this out, a lot of internal prototyping as well, a few hard projects that we had to prototype and prove to everyone that this works and it's better. And by the time we actually started for the company, everybody were like, we needed this yesterday. Where were you all this time? And so we decided to do all this at the same time. CI, CD, we made an unversioning exercise across the whole company. We were doing coordinated releases a lot, like the 10+ releases before CI/CD, and instead we now made it that all services have only git commit as the version. That's about it. So there is no semantic versioning for services. We use semantic versioning only for libraries. All services just have git commit as the version, and that's about it. So Dockerizing Kubernetes. So this was the main focus of our whole effort. Right? And we could not have done this without support from across the organization. So this part really mattered. We had to take support from the teams, from the product owners, from the managers, from the business people. Business people were willing enough at a point to say that we are ready to take risks, and risks mean downtime. Like when you're doing such a huge change, and when you suddenly have a 2-hour or 3-hour downtime or revenue loss, then it reflects really badly. It puts a black mark on your whole effort. So we had to have everybody on board before we started this out. And we did not try to change the whole world at the same time. Like, in the conference, we see a lot of things, a lot of cool things happening, like, Prometheus, monitoring stack, logging, Fluentd, a lot of things happening, right? But we did not want to jump into everything at the same time. This was already big enough as it gets, right? And the second thing that we did is, wherever possible, we tried to migrate applications as they are. We did not try to, make them 12-factor in the process of migration. Like that could have just, we couldn't have put a timeline to it at all then. So we profiled a lot of our services. There were some services that were close to 12-factor. There were some services which were not, but they had a very small dependency graph. And then there were like a few services which were really hard legacy challenges. And we always split the migration that we were tackling all three at the same time. Like, we had one prototype project with a really hard legacy service. We proved that this can be done with that service. Like, it was a SBT play framework, stateful singleton application, and a very core piece of our business. And we started with that, and we proved that we can do for that. And then at the same time, we had smaller, we were also focusing in bulk on these services as well. So we were trying a profiled approach and always balancing out which services were, getting to CI/CD, Kubernetes, and everything, because we didn't want to come to the legacy challenges in the end and suddenly hit a whole new wall. Yeah. So what this means is that if some of these services took 5 minutes to boot up, if they had a 600 megabyte container image, if they had all those dev and ops hacks, we don't care. We are not fixing it. Like we are first. Oops, sorry. Yeah. So we are first establishing the pipe for them. And once we establish the pipe, once we empower our developers, they are smart enough to optimize the pipe from there. Yeah. Also, multiple approaches, like we containerized a few services without actually serving traffic for people to test. We did shadow comparison, traffic routing, check the metrics, check the logs, like check the metrics and logs of the service which is not serving all the new customers, right? So we did all of these to migrate most of our services. The other thing that we learned is work closely with the feature teams. Like if it means that you have to get out of the DevOps desk or team or whatever you are sitting close together, it means yes, like just get out of the desk and go and be part of the developer journeys, like go and be part of the feature teams and help them, work with them, let them own their success, let them go and present to their company what they have done and how things are better for them now. It's okay to own the failures, but it's okay to distribute the success and avoid the same mistake that we have done for all the years, like dev and ops silos. We don't want to repeat that when migrating to Kubernetes, right? We just don't want to do it under a new name. And the other thing that we learned, again, more and more learnings, is that embrace standards, pick a standard. Like today, like DevOps tools is more like a 4-year back NPM landscape where you had hundreds of micro.js libraries, 2 KB micro.js libraries every single week. Now it's just 2 MB Golang binaries. So there are a lot of tools coming up, and you have to choose really wisely, you have to choose really well, and you have to always be into an ecosystem rather than trying to invent your own format or standard, right? And what we do is whenever we are in doubt about a standard, we just validate, like we just enforce a subset of it, like the same way how we enforce a subset of GitLab CI.yaml, a subset of the Helm chart, or and a subset of the Kubernetes API. So we always enforce a subset through validation, linting, whatever possible means, through testing sometimes, unit tests. And so that's how we evaluate a standard, and then later we choose to decide, okay, whether let's now move this out across the board. And whatever we developed, we just dog-fooded it to ourselves first, like DevOps first used it to deploy our own services. And we had a very early on decision that we will create very little command line tools, and wherever possible, Docker and kubectl should be our, like official Docker and kubectl unpatched should be our favorable tools, like probably the only tools that developers work with. And so this is like, it's a long list, like this is a list of all the projects that we transition. Every single one is a journey, and every single one is a success story. So what Kubernetes enabled us, like Kubernetes was what enabled this whole transition for us. Like, previously, you had to create cloud images and then do Terraform and then manipulate physical resources. Like when cloud first came, cloud was called virtual. And now that Kubernetes is here, cloud is now called as physical and Kubernetes is called as virtual. So I don't know the lines between what physical and virtual means anymore. So it's like, so we got from physical to virtual resources purely because Kubernetes makes it really easy for a developer to write a YAML and manipulate their own resources the same way DevOps used to manipulate the cloud. Like instead of an instance group, we were using a deployment. Instead of a load balancer, we were using a service. And instead of disk images, it's Docker images. So we're just translating one-on-one cloud setup into a Kubernetes setup. And yeah, we just moved from Packer build to kubectl apply. And this is safe enough that we can give full control to our developers, because this one, nobody really feels comfortable distributing to every team, because it's very hard to control, and it also involves real resources which cost money. Right? So Kubernetes is what really enabled us to deliver this whole pipe. Like, there are individual solutions in each step for YAML sharing, or for development, or for CI, or for CD, and for deployment, but Kubernetes is an underpinning behind all of this. And Kubernetes also enabled us to transition legacy and modern services. Like, we are still running 400 MB services. We are still running, 4-minute, 5-minute boot up time services. And Kubernetes allowed us to transition all those. Yeah. So stepping forward, what we would like to do going forward is that, so we started with engineering, and then we tackled CI, CD, tooling, value-added services, and then we have to automate our infrastructure. And once we reach all these, once we raise the bar across all this, then finally we can do site reliability engineering. Like, once all our applications can do continuous delivery, we can make sure that, once all our applications have compatibility policies, like if every single release is compatible with the previous, right? Then what we can do is we can automatically make prod mean prod 0 or prod 1%. Like, right now they are deploying to 100% of prod traffic without changing any of their processes. We can just say that whenever they mean I want to deploy to prod, like when they say environment prod, we can deploy it to a 10% or 1% or 0% prod cluster. And from there, we can sync to all the other clusters based on metric stability and so on. Right? So, but we have to cross all these to do this. We also want to do better state management. So, the Y8S service is good, like it's easy to use, but at the same time, you have to clean up afterwards. Like, whenever you change the deployment labels, or when you rename a service, you have to go and manually clean up the old service. Like, that's what Helm is really good at. Helm is able to convert this whole thing into one atomic transaction, clean up everything, and then run the new services. So we would like to move slowly to better state management. There are multiple ways of doing it. And we also want to do secret management. Again, we don't want to leave our payment gateways and so on, like all the other secrets lying around in disk in the application developer repositories. Like, we can't make sure that all the application developers have all this really figured out. So rather, we would want to move to some form of secret management, not necessarily at runtime, but also during CI time, or during deploy time, or in the compliance gateway. Like, there are multiple layers where we can do this. We want to move to ingress and the federation plane. If a service is down in one region, we want calls to it to go to another region. And we also want to enable namespace quotas, and finally have a sense of how much resources is each namespace really using. Like, we don't want a service that is handling 1% of traffic to consume 99% of production resources. So this is what we would like to stepping forward. So this does not cover, as I said before, like we did not try to change any of our monitoring, logging, and all the other stacks. Like, we kept stuff as it is. So, but this is purely our CI/CD dev to prod transition. And if you have any other questions, I'll be happy to answer.